All right, so this is for question 44. As you can see, I've already worked through it once, but then when I got to the end of it, I was like, oh man, I think I did something wrong. So I went back and I identified where I made my mistake, and I'm kind of here to make a fresh video, talk us through it. So I've got these two stars that are going to be orbiting each other, because if they were starting stationary, they would just kind of get sucked in towards each other. So the only way that they stay separate is because they are orbiting each other. So they're kind of sweeping out this circle. Now the mistake that I made, and I think honestly I made it with you guys before in the past, is that they're each sweeping out a circle, but they're not sweeping out the same size circle. So you can kind of see from this picture over here that the one that's more massive, so the 6 times 10 to the 30th, it sweeps this small circle out, and the smaller one is across from it, and so the distance between the two of them will still be the 2.0 times 10 to the 12th described in the problem, but essentially this one's sweeping out a small circle, and this one's sweeping out a much larger circle than this one. But going back to kind of my main drawing, anytime I've got two masses out in space, I mean really anywhere, they're going to pull on each other. So I set up a force of gravity equals gmm over r squared, plugged in my two masses, the distance between them. So in this FG equation, the distance between them is not a radius so much as it is a distance. So that's the 2 times 10 to the 12th. That's how far it is between the two. So we can do that, and we can calculate how much force of gravity is pulling these towards each other. But before we get into the actual circular orbit of things, we need to do the math to figure out where is the center of mass, because that's what it's going to orbit around. So mass times distance plus mass times distance all over total mass will tell me where my center of mass is. I took my 6 times 10 to the 30th mass as the temporary 0, and I said it was 0 from that spot, but the other one was the full 2 times 10 to the 12th meters from that spot, and I got that the center of mass is 0.5 times 10 to the 12th from where I called 0, which was the 6 times 10 to the 30th. So I drew a little picture. To the center, 6 times 10 to the 30th is 0.5 times 10 to the 12th from the center of mass, which leaves a remaining 1.5 times 10 to the 12th to finish going around. Okay. So when I talk about the force that's pulling us in a circle, well, both of them experience the same force because of Newton's third law, equal and opposite. But then I say, which object am I focusing on traveling in a circle? So first I did the 2 times 10 to the 30th. So 2 times 10 to the 30th times v squared. I didn't know what v is. And the radius here, r, does not stand for distance so much as it really does mean radius right here. So I have to plug in the radius of the small mass, the 2 times 10 to the 30th circle. And so that's radius is 1.5 times 10 to the 12th. Rearrange things, and I get the speed of that one as 12,247. I repeat exactly the same process for the bigger one, but this time I use the mass as the 6 times 10 to the 30th because that is the object that's traveling in a circle. And the radius of the circle that it's traveling is just the 0.5. So I get a speed 4,082. And I can plug that into v equals 2 pi r over t. Move things around. Speed, again, it's the radius of the circle that we're on. Did I write that wrong? Oh, I think I fixed this in my calculator, but I didn't fix it on the page, so let me fix it on the page. Yeah, here it was 0.5 times 10 to the 12th, and here yeah, I did the math correct. I just didn't show the work fully. So 1.5. And the result is they get the same period. So both of these objects are taking the same amount of time to do their circle. So they're always going to stay opposite of each other, even though they're moving at different speeds on different size circles. Okay? Anyway, that's question 44. Hope that helped.